Hi, this is Rajshekar, Assistant Professor in EEE Department. Through this video, I am going to introduce the concept of locational marginal price. Now, let us take one small example where two generators G1 and G2 are supplying a load of 500 megawatts and 400 megawatts. Here in the table of G1, I have shown a piecewise cost function of generator 1 and generator 2. The generator 1 for supplying 400 megawatts of load, it is the cost of generation is $5 per megawatt hour, and for the same generator if it wants to supply 800 megawatts, the cost of generation is $7.20 per megawatt hour. Similarly for generator 2, 200 megawatts it is 6.5, and for 400 megawatts it is 8. That means if generator 1 is supplying less than 400 megawatts, then the cost of generation is 5. If it is generating 800 megawatts, that is more than 400 plus, then it is $7.20. So taking this concept, two generator system, now if a 500 megawatts plus 400 megawatts, that is total 900 megawatts of load is to be met with the help of two generators who has different uh, cost of generation. How this LMP is going to calculated, we are going to see. Now let us define LMP. LMP is at a location is defined as marginal cost of supplying an additional increment of load without violating the security limits. Let us see in the next slide how this LMP concept is explained. Let us now explain the concept of LMP through this slide. So, generator G1 and generator G2 are supplying total 900 megawatts of power. So, how these 900 megawatts are selected? When there is no transmission limit. That means there is this transmission line can accommodate any amount of power. Let us assume. Then the first 400 megawatts is selected from generator 1 because the cost of generation is less. Out of the 4 segments that are available, the least cost of generation 400 is selected. So the generator 1 is supplying 400 megawatts plus. Now actually the total power required is 900. So the next available power after 400 is it is 6.50 of generator 2. So the cost of generation of generator 2 is 6.5 and corresponding value is 200 megawatts. So 200 megawatts is selected. So the second block selected is 200 megawatts from the generator 2. Similarly, now the total 400 plus 200 it is 600, but we need 900. So the next block which we can select is out of these 4, the next which is having the next highest is it is 7.20 from generator 1. So this generator 1 block 2 is selected. Now since 800 megawatts it can generate, but we require only 300. So from the 800 available generation, we are drawing only 300. So the generator 1 is supplying total 700 megawatts and generator 2 is supplying total 200 megawatts, which is equal to total 900 megawatts. Now the transmission line is carrying 200 megawatts of power. Since $5 per megawatt hour power is being consumed and 200, that is $6.50 per megawatt power is also being consumed, it is fully utilized, and next comes 300, that is 300 megawatts with $7.20 per megawatt power is getting consumed. Now as per the definition, LMP is nothing but supplying the extra additional megawatt of power. Suppose if I want 901 megawatt of power, that extra 1 megawatt of power can be supplied at a cost of 7.20. Now this $7.20 per megawatt will become the LMP at each bus. That means generator 1 LMP will be $7.20 per megawatt hour, and generator 2 LMP is 7.20, because uh, out of 800 we are using only 300 megawatts, and still we can use 500 megawatts of load from generator 1, and that generator can supply the power at a cost of $7.20 per megawatt hour. That means the next 1 megawatt of power can be purchased at 7.20 megawatt dollar per megawatt hour. Now let us see how the LMP varies when there is a limit on the transmission line. For the same system which I considered earlier, let us say that transmission line which is carrying power from generator 1 to generator 2 is limited to 100 megawatts. That means the line can hold only 100 megawatts of power. Now, for the same scenario, if generator 1 is supplying 400 plus 300 in the earlier case, now it can only supply 200 megawatt, because the transmission line is limited to 100 megawatts. So the total 900 megawatts is to be met by taking the other block into consideration. That is, from generator 2 only we have to take the other 100 megawatts which is limited by the transmission line. That means that 400 out of 400 megawatts we have to generate 100 megawatts at a cost of $8 per megawatt hour from generator 2 to meet the load of 400 megawatts. Now, since we are using the power from generator 2 at $8 per megawatt hour at bus 2, now the LMP at bus 2 becomes $8 per megawatt hour, and since the load at bus 1 or generator 1, which is consuming the power from the generator 1 only, so the generator 1 is supplying the power at $7.20 per megawatt hour. So the generator 1 LMP becomes $7.20 per megawatt hour, and generator 2 LMP will become $8 per megawatt hour. So to conclude, if none of the transmission lines are at maximum flow, that means no transmission limits are there, then LMP values will be same. If the transmission line are limited, that means if there is any limits on the transmission line, LMP will be different at each bus. So I hope I have explained the concept of LMP, and please do subscribe to my channel and watch for more videos. Thank you for watching my